my name is Diana and I'll be doing question number 1 from the math packet. And question number 1 reads,
Ship A is traveling due west toward Lighthouse Rock at a speed of 15 kilometers per hour. Ship B is traveling due north away from Lighthouse Rock at a speed of 10 kilometers per hour. Let x be the distance between Ship A and Lighthouse Rock at time t, and let y be the distance between Ship B and Lighthouse Rock at time t. Let theta be the angle formed between the segment joining Ship A and Ship B and the segment joining Ship A and the Lighthouse Rock. A. Find the distance in kilometers between Ship A and Ship B when x equals 4 kilometers and y equals 3 kilometers. Part B. Find the rate of change in kilometers per hour of the distance between the two ships when x equals 4 kilometers and y equals 3 kilometers. And Part C. Find the rate of change of theta in radians per hour when x equals 4 kilometers and y equals 3 kilometers.
as you can see, the distance between Ship A and the Lighthouse Rock is described as x, and the distance between Ship B and the Lighthouse Rock is y. This is the hypotenuse, this would be the opposite, and then x would be the adjacent. To find the distance, all you really got to do is plug in the 4 kilometers and the 3 kilometers. So you take the square root of 3 squared plus 4 squared, which is your 5 kilometers, and that would be your distance from Ship A to Ship B. And that's your answer for A, it's 5 kilometers. Okay, so after you get your 5 kilometers, then you can go ahead and put it here, which means your dt is equal to 5 kilometers. And then you can go ahead and start question B, or part B, which reads, find the rate of change in kilometers per hour of the distance between the two ships when x equals 4 kilometers and y equals 3 kilometers. So then you're going to have to use the Pythagorean theorem to find this equation, which is obviously, this is r. So r squared equals x squared plus y squared. And then you're going to use the chain rule to differentiate the two parts. Afterwards, you're going to put them at x equals 4 and y equals 3. So then we're going to separate here, and then just know that when x equals 4, x is from A to Lighthouse. So then this would be x, which is 15, and then this would be y, which is 10, because as you can see, y is from B to the Lighthouse Rock, and then you just plug in those numbers. X equals 4, so then it's 4 times the negative 15, plus the 3 times 10, 3 because of x equals y equals 3, which is given in your problem, and then 10 kilometers per hour, which is the speed of the boat going northbound. And then you add those, and then you put that all over 5, which is your distance traveled from A to B, which was the distance we got in part A. And then once you do that whole equation, you're going to get negative 6 kilometers per hour, which is your rate of change. Okay, so to find part C, first you got to know what you're asking for. Part C asks to find the rate of change of theta in radians per hour when x equals 4 and y equals 3. So just to make life easier, we're going to go ahead and put that on our diagram so you can visualize it if you're a visual learner. I know I am. So we're going to go over here to our little diagram of where the ship in the Lighthouse Rock is, and we're going to just simply put the numbers. If x equals 4 and y equals 3, so you're going to put the x here and the y here. That way, when it comes to doing your tangents, your sines, and your opposite and adjacents, then you know what you're doing. Okay, so then to answer part C, you're going to need to put them all in terms of x and y, and that's how you get the expression for theta in terms of x and y, which is tangent theta y over x. If you don't know this, here's a little trick for you guys. Just do SOHCAHTOA, and then that way you'll never forget. So basically, sine, cosine, tangent, you need tangent because it's in terms of x and y, which means it's opposite over adjacent. Same thing, sine is opposite over hypotenuse, adjacent over hypotenuse, things like that. So just remember SOHCAHTOA, you'll never be lost. And then after you put them in terms of x and y, you're going to differentiate in terms of t. Okay, so to find the derivative, you're going to have to use the quotient rule. This is how you're going to set it up. If you don't know what the quotient rule is, you're going to do so let's say y prime equals top times the bottom. You're going to derive the bottom, then you're going to subtract that from the top times the bottom, and then that way you'll do the prime of t over bottom squared. So it's top bottom differentiated minus top bottom, but the top is going to be differentiated in that term. So all of that is going to be over bottom squared. So that's what this is basically. So you can see bottom squared. And then all you gotta do is just plug in x equals 4, y equals 3, and secant theta is 5 over 4. Now, why is 5 over 4, or why is secant theta 5 over 4? Well, if you follow me over here, and you remember SOHCAHTOA, then you know SOHCAHTOA. And you know that secant is the opposite of cosine. So basically, you do it backwards. You do hypotenuse over adjacent. So you go to your graph, you go to your hypotenuse, which is 5, and then your adjacent is 4. So then you plug it in, and secant theta is 5 over 4. Okay, so to get d theta over dt alone, so that you can finish your quotient rule, you're going to have to get secant squared theta and move it right over here. After doing that, then all you really got to do is plug in your x equals 4, y equals 3, and secant theta is 5 over 4. After putting all those numbers, you'll get 85 over 25. But obviously that number is way too big, so you got to simplify it. And then it would be 17 over 5 radians per hour. And that is your rate of change in terms of theta.
Hi, I'm Patty, and we're going to be doing question number 3 for Math 2311. Question number 3 reads, the television camera at ground level is filming the liftoff of a space shuttle that is rising vertically according to the position equation S equals 50t squared, where S is measured in feet and t is measured in seconds. If the camera is 2,000 feet from the launch pad, find the rate of change in the angle of elevation of the camera at 10 seconds after liftoff. Okay, so with this information, we have that S is the height of the triangle and 2,000 feet is the base of the triangle. With the Pythagorean theorem, we get that S squared plus 2,000 squared, we square root that, and that's the hypotenuse. With that, we get that cosine of theta equals 2,000 over S squared plus 2,000 squared, the square root of that. So we have from the question that S equals 50t squared. When you get t that was given to us, which is 10, and you plug it into S, you get 2,000. Now all this, you need to set it up now and you're going to use it later on in the question. So first we're going to take the derivative of S, which is 100t. Then we're going to do tan theta equals S over 2,000, which is the opposite over the adjacent. So you're going to take the derivative of both sides, which equals secant squared of theta of d theta over dt equals 1 over 2,000 ds over dt. So you're going to want to isolate the d theta over dt, which equals 1 over 2,000 secant squared ds dt. Now, the inverse of secant squared is cosine squared. So you end up getting cosine squared over theta of theta over 2,000 ds dt. Now, with the inverse that we took of S, we're going to get 100t over 2,000 and we're going to multiply it with cosine squared. Now, cosine is 2,000 over the square root of S squared plus 2,000 squared. So we're going to plug that in here and we're going to end up getting 100t over 2,000 times 2,000 over the square root of S squared plus 2,000 squared. And you're going to square that also. Now this is going to cancel out and the square root is going to cancel out. And then you're going to multiply these two and you're going to get this. 100 plus 2,000 over S squared plus 2,000 squared. And then you're just going to plug in your t that you got in the beginning of the equation and you end up getting 2 over 29 radians per second. And that is how you solve the equation.